times gotten more than 5 minutes, and a lot of it is because this precision calculation takes so long. So I'm going to go ahead and run it at the beginning of my video. You can see it's at the training job's finished now. It's just got to make the predictions, which takes a while. This is the configuration I've used. We see that I'm doing it for 10. I have to set his ranking for true, otherwise these 10 values won't get fed into the precision evaluator, and instead the precision evaluator will just try and compare 0 items to 0 items, so we would get not a number for the evaluation, and that's a problem. So all that aside, I already actually have a video out there, but I'm going to use this video to basically repeat what I said before, but with a few differences. First of all, this beta field I added in here in order to do the beta similarity weighting based on the number of items that both users have ranked. Everything else is pretty much the same, except for in this class we had before, and I actually have it pulled up here, we have this is ranking thing, and it was summing up just the user entry values. These are the user similarities, and all it's doing, if we set that is ranking parameter to true, is summing up all of the user similarities. So even if we weigh the user similarities, that's great, but it's not multiplying it that like it is down here by the rating. And that's what's important, because we want to take the rating of the item that we care about and multiply it by we want the rating of the item that we care about for a user that we have the rating for. We want to take the similarity of that user to the user that we're trying to get this rating for, and then multiply the two together. If we're just doing this ranking similarity, we're not taking the rating of the item of the similar user into account at all. So yeah, that's just a garbage method. So here we go. I guess that's for unary data, but I have my reservations about that as well. So here is the existing rating and ranking item that we're now doing for both rating and ranking. And it's the same as it was before. It's taking the difference in the user rating, the user that we have the known rating for, and that mean of that user's ratings, just so we have a normalized rating, and it's multiplying it by this user similarity function. Here's where we get the user similarity function, and it's a little bit different to get the adjusted similarity ranking. So we go ahead and we get, to get this adjusted similarity ranking, we get a set of items that both users have rated. So we do this for every user, and for every user, we get the items that each user has rated. We see what items overlap, and then we get the number of those items. And then if that number of items is less than our beta, we penalize the similarity term by the ratio of that smaller number of items to the beta that we gave it. So if we had a beta of 10, for example, and the overlap was 5, we would divide the similarity between these two users by 2. And then we just return that similarity. So we were returning that similarity before in the original user KNN. We're still returning a user similarity decimal, but now it's going to be a little lower for items where the overlap is a little bit less than beta. So that's the whole thing. That's the whole ranking. So we ran it, and we see here is our. It's now getting back to the function that we just ran, the precision evaluation. We see that we have 0.013, and if we go over and we switch over to the other function by commenting out these lines of code and commenting in these lines, this one runs a little bit faster, so I'm not worried about running it right here. It still takes its time, but it's not nearly as bad as a precision evaluation. So we have ratings for both. That's the whole thing. Thanks for watching.